Okay, so I knew I would get questions once I was doing multiplication of larger numbers about division strategies for larger numbers as well. Now, my students don't usually see these division strategies until probably late February, early March, depending on our expectation, how far we get into our curriculum. But I always do start with jump to a landmark number. You'll notice on our previous anchor chart, this is where we left off with division. So again, I want them to move away from drawing four dots, four dots, four dots until we have 56 dots. It's inefficient. It takes a long time. So some of my students will know to start, they like to start out with 10 times 4 is 40. Some of them, you will see them draw it this way, where the times 4 is 40. Now, whatever the number that's the same or at the bottom of your tower, that's how you know what to add. So then we would keep going with 44, 48, 52, 56. Now we're not going to put 56 as our quotient answer over here. Of course, we talk about how do you use a multiple tower, how to use multiples to find that quotient answer. Well, if this is your 10, this must be 11, 12, 13, 14. So our quotient answer for that one will be our 14. Our next strategy we're going to look at is a break apart strategy. Now, this one I can tell you can be very confusing because for students who latch on to it during multiplication, they have to know how to break it apart. Again, you are going to jump to that landmark number where we're going to start with that 10 times 8 is 80. Now, this is the part we're not at 120 yet. So they need to think about, what would I add to 80 to get to 120? Can I do another 10? The answer is no. Could I do 5? Well, 5 would be 40, so 80 plus 40 would get me to that 120. So how many 8s fit into 40? We said 5. Now this is where it can get super confusing for students, is where's the quotient answer here? So we have to talk about how we knew the 8 was part of our equation, and this is our 120. So we already knew that answer. The part we didn't know was this part over here, the 10 and the 5, which would give us a 15 as our quotient answer. Our next strategy that I introduce is going to be our area model. Now, I will admit I do have coworkers who absolutely do not like this strategy for division. So it's kind of up to you, but I do have students who are so attached to it for multiplication that they very much want to be able to use it for division as well. So with this, we talk about, well, the short side goes over here with our 6, but we don't just automatically put the 100, the 30, and the 2 up here like we do with area model. So with this, the 132 actually goes in the box, and we have to think about how many 6s would fit into 132 without going over, and that can be completely overwhelming. So the question I always ask, notice I'm always asking questions, I'm not giving students anything, is, well, could we start with a 6 times a 10? And hopefully they'd say yes. Now you could do the 10 up here, but I like to encourage them to jump to the next 10 and say, well, could we do 6 times 20 then? Hopefully somebody will say, oh, 60 plus 60, 120, or 12 with a 0, so yes. So then my next question would be, could we do 30? Hopefully somebody would say 6, 12, 18, that would be 180. So no, we can't do 30. So I would tell them, okay, so we got to stick at 20. We're going to put the 20 up here at the top. And you told me that 20 times 6 was 120. So we're going to take that away and see what do we have left. Now we can't have a remainder of 12 because that is bigger than this number here in our equation. So we've got to take our 12 and we're going to put it up over here in the box. We're going to ask how many 6s fit into 12 without going over. That without going over is really important because then it helps them understand the idea of remainders. And we've kind of explored that at this point by the time I introduce these, not necessarily with numbers that quite this large. However, that's a video for another time. So hopefully all of your learners will be able to tell you 2 6s fit into 12 without going over. So the 2 actually goes at the top. You're going to take away the 12 to get your remainder. So here's where it does get a little confusing. Again, you can ask them, where do we find our quotient answer? Most of them will understand that the part we didn't know was the part at the top, the 20 and the 2, which would give us a quotient answer of 22. Now, my state standards, my curriculum does not require that I teach long division, which I'm glad because, again, I don't really have time to just jump into long division. I would prefer to teach these strategies first, then have my 5th grade teachers reinforce it, because this is where my 5th grade teachers start right away and they can always depend on these strategies. So let's start with 90 divided by 5. Now, for some of them, could they count 5s up to 90? Yes, but I do this strategy because some of them really dislike this strategy. So if it's one where they feel like they know the quotient answer already, they are just a little more open to trying it. Now, this division symbol right here doesn't really have a universal name. I give it a silly name. I call it the garage. And we talk about how we put the bigger number in the garage and the smaller number on the outside. And then we ask ourselves how many 5s fit into 90 without going over. So again, I ask them, could we do 5 times 10? Hopefully they'll say yes. And then I tell them, stack it up. So the 10 goes up here. Then I have to ask, what is 10 times 5? Well, it's 50, so we're going to take it away. And you've probably noticed that this is very similar to long division and will lead them toward that. But again, we're giving them a foundation of why you do what you do with long division without just teaching them a math trick that isn't based in place value numbers. Then we have to ask ourselves, now the 40 is bigger than this number, so 40 cannot be our remainder. So how many 5s fit into 40 without going over? Hopefully they'll be able to count through and give you the 8, and I tell them, stack it up. What is 8 times 5? It is 40, and we do not have a remainder for this one. So again, I can ask them, okay, but where do we find our quotient answer? And most of them will tell you it's at the top, that we have to take these 2 numbers and add them together. So that's the strategy I teach before they are introduced to long division. If it is required by your state, I totally understand that. I usually take an 8.5 by 11 or a piece of construction paper and cut off the bottom. And I would do these 4 strategies first personally, then cover it up and eventually introduce long division. That is just me. I like it based in those facts first. So we're constantly reinforcing those facts before I teach them what feels more like a math trick. It'll seem quick and easy right away, but my students can fix mistakes with these strategies much more efficiently than they can with an algorithm. So just my 2 cents worth.